This is a little review to help you calculate. Let's say you hypothetically had to do a hydrate lab, and let's say it was due tomorrow. Then let's say you were panicking, let's say, hypothetically. Anyway, if you had to calculate a hydrate lab, first of all, the purpose of a hydrate lab is you take a compound that has water in its ionic crystal. Like you see right here, this is CuSO4, copper sulfate with pentahydrate. It's got 5 water molecules in it, in its crystals. Basically, what you would do is you would put it on a Bunsen burner in one of these crucibles. You would light it on fire. It would burn, and then basically what you're going to do is get rid of the water. And the whole purpose of doing the lab is for you to find out the unknown amount or the ratio of the hydrate. So I'm going to use copper sulfate as an example. Your hydrate doesn't have to be blue; it could be white, but the mass will change as you heat it. Once you heat it, you'll see the color change a little bit because as you drive the water off the crystal, it changes a little bit. So let's talk about the calculations. Well, first of all, here's a pseudo data table. First thing you're going to do is you're going to take your crucible, you're going to wash it, and then with a little lid, you're going to heat it, and then you're going to record the mass of the empty container. So let's say, I'm going to just make this up, the mass of my crucible was 51 grams. Then what I have to do is, let's say according to my lab, I had to put 3 grams of the hydrate into my crucible. So when I weigh it back on the balance, it weighs 54.02 grams. Then I'm going to sit and I'm going to heat it. So I'm going to heat it a couple different times over and over and over. And after heating it like 3 times, I put it on the balance and it weighs 52. Hold on a second. It weighs 52.94 grams. Then I have everything I need to do my calculations. First step is I'm going to find the mass of my hydrate. How am I going to do that? I take the original amount, which was the empty crucible. This is just the crucible. The second number is the crucible and the sample. So I can find my hydrate by just taking basically 54.02 minus 51. I'm going to end up with 3.02 grams of just my hydrate. So this is my hydrate here. But after heating it 3 times, what I've done is I've gotten rid of the water. So this would be without my water. So all I have to do then is do this. I take the mass before I started with the sample in there minus my last number. That's going to tell me the grams of anhydrate I have because the water is going to all be gone if you heated it right. So if I take 54.02, so I'm going to take 54.02 and I'm going to subtract 52.94. I am going to get, that's going to tell me the amount of water I drove off. So that's the amount of water. When I subtract this from this, the difference is going to be the water that's missing that I basically got out of there. So 1.08 grams of water. Well, if I took off 1.08 grams of water, and then this is my original hydrate, I just, after subtracting 54.02 minus 54.94, getting that number, amount of water that's gone, I subtracted from my original amount of what my hydrate was. So if I take 3.02, so I'm going to take 3.02 minus 1.08, and ultimately I'm going to be left with 1.94 grams. That is going to be grams of my anhydrate. I already had the water from the first subtraction from here, so now I have grams of water and I have grams of anhydrate. The next step is to convert for moles of each. So I'm going to come over here. I'm going to take 1.08 grams of water, divide by the molar mass of water, which we know is 18. So I'm going to go 1.08 divided by 18, and I'm going to get 0.060 moles of agua fresca or water. Then I'm going to come back over here. I'm going to take my 1.94. I have 1.94 grams of anhydrate. Now, you'll have an unknown in your lab, and the teacher will list on the lab. Usually what the teacher does is list on the lab sheet what the molar mass of the anhydrate is. So you'll be able to look it up on your lab sheet. I'm using copper sulfate, so the mass of just this is 159.6, but it'll be listed on your lab sheet. So then what I do is I take 1.94 divided by 159.6. So 1.94 divided by 159.6, and I get 0.0122 moles of anhydrate, and I'm almost done. The last step is to get the ratio for our compound. All you have to do is stack moles of water on top, moles of anhydrate on the bottom, and divide the two numbers. Yeah, that's it. So all I'm going to do is take my moles of water, 0.060 moles of water goes on top. I'm going to take my 0.0122 moles of anhydrate on the bottom, and then I'm going to do this. I'm going to go 0.060 divided by 0.0122, and bam, I get 4.92. This has to be a whole number. It's got to be a whole number, but what you can do is whatever you get, you're going to round. You're just going to round the closest whole number. So the closest whole number to 4.92 means 5. What does that mean? That's going to tell me the moles of water compared to the moles of the anhydrate. If I go back to my copper sulfate example, remember it's CuSO4.5H2O. That number, when you're done, will tell you basically the moles of water. So that's what you're getting. When I go over here and I divide, when I take double stack, I put the moles of water on the top divided by moles of anhydrate. This is basically, you're getting the coefficient of water is what you're getting. You're getting the coefficient of water, and then once you know the coefficient of water, you can go back and look and identify, because each of the unknowns has a different coefficient for water, and then you go back and you can figure out what your unknown was. All right? That's it. It's easy. All you have to do is keep track. Just remember, empty container minus the first one will give you the total hydrate. The second one minus the final one, so with the sample after it's been heated, is going to give you the amount of water. You subtract that number from the hydrate, will tell you the amount of anhydrate. Then you're just going to convert them to moles, which is easy. You know the molar mass of water. The molar mass of anhydrate will be provided for you on the lab sheet. And the last step is just to double stack that sucker. Moles of water on the top, moles of water anhydrate on the bottom, and bam. Closest whole number gives you the coefficient of water, and you're good to go. All right?